Alright, guys and girls, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. And today's last notes, oh, it's frozen. Last notes for this unit is going to be about imaginary numbers and the discriminant. Oh boy. Okay, so, we've been solving for x, right? We've been finding different solutions. And there's different types of solutions, okay? You may have noticed that sometimes your solutions are just real numbers, They're numbers, there's no square roots or radicals attached to those numbers. But sometimes in your answers, you do have radicals and you do have square roots in them when you have like 2 plus or minus square root of whatever, So we have different names for those types of solutions. So when you have real solutions that don't have any square roots, those are called rational solutions, okay? You know what rational means? Like the word rational? Like what? Like if you ask somebody, are you being rational? Do you know what that means?
Are you making sense?
It's are you making sense? Are you making sense? Are you being reasonable? Right? So a good way to remember rational solutions is just these are the numbers that make the most sense. They're just numbers with no square roots. So for example, you can have For example, rational solutions would be things like 1 or -2 or 1/2. These numbers make sense to us. Bless you. All right. Can somebody else, but still, right? You understand that. That's just a number. There's no square roots on it. These are rational numbers. Can you give me another example? Anything? 11, right. So that's a rational number. Good, okay? So now real solutions that do have square roots in them are called irrational solutions. And that's because you don't exactly know what it is because usually they're decimals that go on forever. When you have square root of 3 or -2 square roots of 5, you can't actually tell me what that number equals, can you? So these are irrational solutions. But they're still real numbers. Can you give me another random example of an irrational solution? Square root of what? Of one, but that's just 1, so that's not actually. You can't have the negative. You guys are making this real hard. Yeah, square root of 7. That works.
Oh, you basically said the same thing.
Okay. All right, so that's what we know so far, okay? That's not really new. Now you just know what those are called, the categories it falls into. So now for the new stuff, we're going to be learning about imaginary numbers. So far you know that whenever you have a square root of a negative number, like square root of -2, we always just wrote no real solutions, right? But that's because there's imaginary solutions. So this is not a real number, square root of -2. If you put it in the calculator or your phone, you see that it's an error or it says no real solutions. So this is an imaginary number. Square root of a negative number is an imaginary number. Other examples will include things like I square roots of 3 or 2i. And we're going to find out what I means in a second, but for now, just write that down. Yeah, right there. So these are called imaginary numbers, or imaginary solutions. And then finally, we have complex numbers, and that's when you're taking real numbers and combining them with imaginary numbers. So, for example, can you give me a real number, any real number? 2. And then can you give me an imaginary number? Square root of -7. So if I put 2 plus square root of -7, you see how we have a real number and then we're combining it with an imaginary number? That right there is a complex number because it takes one of both. Other examples include things like 1 plus or minus I square roots of 5. Things like this. All right, so now we see these i's, okay, and we're going to see what it actually is. So simplifying using the imaginary number I. I is an imaginary number. So why can't you get the square root of a negative number? Does anybody know? Why can't you have a square root of a negative number? That's right. So a negative times negative is a positive. So that comes out to be positive. And also positive times positive is a positive. So for example, like 2 times 2, what's that? 4. What's -2 times -2? 4. There's no way you're going to multiply a number by itself and get a negative number, right? That's why you can't have square root of a negative number. But this is where the imaginary number I comes in, because I times itself equals -1. See, that's not a real thing, but with I, we can imagine this happening. I times I is -1, which means that I by itself is the square root of -1. Yeah. But using it in practice is actually really easy, though. So on number 1, we're going to simplify each number using the imaginary number I. So all you have to think about right here is, you see a square root of a -4, right? So all I want to do is, I don't want the negative under the square root, so all I have to do is take the I out. I, square roots of +4. That's it. You see a negative under the square root? To get rid of it, just bring the I on the outside. And then it becomes positive. But after that, you want to simplify that square root expression. So what is the square root of 4, though? 2. So we just write 2i. And that's it. You want to put 2i, just like you don't write x2 or y2, you write 2x or 2y, right? Same idea.
So we have to write I, and then, so then for example, number 2 would be I square root of 7 now?
That's right. Number 2 is I square roots of 7. That's it.
Once negative, that's what you give?
Yeah, exactly.
Okay.
To get rid of that negative, you bring the I out. I is that imaginary number. Imaginary numbers in the imagination world. What's number 3 then?
I square root of 15.
That's right, I square roots of 15. This is because we can't simplify those square roots. But on number 4, what will we do first?
Simplify it.
What will we do very first, though? First, we're going to... I square roots of 50. No, I square roots of 50. And then
You
simplify.
simplify.
So what can square root of 50 break down into? 5 and 10. What are some other numbers I could... 25 and 2. So we're going to put I square roots of 25 times square roots of 2. Okay? And then what can we do from there?
Simplify the 25.
Right, simplify the square root of 25. What is square root of 25?
5.
So it's going to be... What's your final answer going to be then? What do you think?
5.
5i square root of 2. That's right, like this. 5i square root of 2. Perfect.
So no plus or minus?
No plus or minus. So when you're dealing with i's, you don't do the plus or minus unless it's in the formula. Okay, so we're going to see right here now, we're actually going to use this idea of I in our quadratic equation, quadratic formula to find answers. But right here, we have plus or minus in the formula, so this time we're going to use plus or minus, okay? All right, so this says solve. Determine if the solutions are real, imaginary, or complex. So we need to find the solution and then tell if it's a real number, if it's an imaginary number, or if it's complex. So first things first, we got to see if it's set equal to 0. Is number 1 set equal to 0?
Yes.
Yes, it is. Is it lined up like it should be?
Yeah.
Yes, highest power to lowest power. X squared, then x, then just the number. So what is the a value here?
2.
What is b?
-3.
And what is c?
5.
That's right. So now we're going to write the formula out. So x equals -b plus or minus square root of b squared minus 4 times a times c all over 2 times a. Let's fill in the parentheses now. What goes in this very first parentheses right there? -3. What goes in the next one in the squared? -3 again because it's b. What goes after the 4? 2. And what goes after that? 5. And what's on the bottom? 2. Okay. So now we got to simplify this. So let's go step by step. What's my next line going to be? What's my next step going to say? X equals 3 plus or minus? Square root of 9. Minus 40. That's right, because -4 times 2 times 5, that's -40. Over?
4.
That's right. All right. What is the next step then? You subtract, right. So we're going to have x equals Negative 31, that's right.
Divided by 4.
Over 4, right. So now we're at this point. What will we do after this, now that we know about I? So what would my next step say then?
X equals 3 plus or no, yeah.
Right, plus or minus?
Square root of 31.
What'd you say?
I square root.
I square root of 31, right. We want to get the negative outside of the square root, so we put the I, and then now it becomes positive
Over 4.
over 4. That's right. We would want to simplify the square root, but can you simplify the square root of 31? No, you can't. So you just leave it like that. Then can we reduce all these terms by the same number? No, so that's the answer right there. X equals 3 plus or minus I square root of 31 over 4. But now we got to tell, is this a real number? Is this an imaginary number? Or is it a complex number?
Imaginary. No, complex.
Complex. That's right. Why do you say complex?
Because it has a.
It has a real number and an imaginary number. See, because on the top it's got a 3. That's a real number, right? Then we got the I square root of 31, which is an imaginary number. So that's complex. If it has an imaginary number and a real number. Because this part's real, right? The 3. But then the I times negative 31 times square root of 31, that's imaginary. All right, let's do number 2 then. Number 2. Is it already in the form that we want it to be in?
Yeah.
Yes, it is. So let's just find A, B, and C. What's A?
1.
A equals 1, right? What's B?
2.
2. And C?
3.
Very good. I'm going to write the formula out. X equals negative B plus or minus square root of B squared minus 4 times A times C over 2A. All right, what goes in the first parentheses? 2. What's next in the next parentheses? 2. What goes after this? 4.
1.
And then after that?
3.
And then on the bottom? Good. All right. So we got to simplify. So what is my next step going to say? Negative 2? Okay. Square root of 4 minus 12. Very good. Over? 2. All right. So that's where we are. What do we got to do after that? Subtract inside the square root, right? So what do we get? What's the whole thing? Over 2, good. And then what? Simplify what? Can't do that yet. Right, we gotta put the imaginary I right there. So what's my next step gonna say?
X equals negative 2 plus or minus I square root of 8 over 2.
Very good. Alrighty, so that's where we're at so far. What comes after this, though? Simplify what? The square root of 8. That's right. We got to simplify the square root of 8 first. You always want to check to see if you can simplify your square root, right? What makes up square root of 8? 2 times 4, right. So we're going to put x equals negative 2. What's after that?
Plus minus
I square root of
2.
4 times square root of 2. Make sure both are under the square root, right? And then over 2.
But then 4 can be simplified by 2 times.
Exactly. So the square root of 4 can turn into a what?
2.
A 2. So now we're going to have x equals
Negative
plus or minus
I
2i. 2i, right?
and
Square root of 2, right. Because the square root of 4 simplifies to just a 2. We still have the I there, and we still have the square root of 2 there.
over 2.
And it's over 2, right? It's still over 2, right? And now this last step is where you reduce. By what?
2.
By 2, right? Because we can divide all 3 of those terms by 2, so we're going to reduce everything by 2. So my final answer should be what? X?
Plus
Negative 1?
plus
Plus or minus? I? Square root of 2? And that's it. right? Because you would have plus or minus like 1i, but there's no point in writing the 1, right? And then it's going to be over 1, but there's no point in putting over 1 either. So we can just leave it at this. X equals negative 1 plus or minus I square root of 2. And is this real, imaginary, or complex? Complex. And why did you say that? There's a negative 1, which is a real number, and then the I, which is imaginary. Very good. Perfect. So let's go to the backside then. The backside is all going to be about the discriminant. The discriminant. Not to be confused with discrimination. Okay, discriminant. This is the part of the quadratic formula that's under the square root. Remember the quadratic formula that looks like that? X equals negative b plus or minus square root of b squared minus 4ac over 2a. The part that's under the square root, that b squared minus 4ac, that's called the discriminant. And the point of the discriminant is, based on the value of the discriminant, it tells you how many solutions there are, and it tells you what kind of solutions there are. Okay, so firstly, if the discriminant b minus 4ac is negative, that tells you there's going to be 2 non-real complex solutions. And you can see, like up here in our example, you see this negative 31 right there? See the negative 31? That's the discriminant, because that's the part that's under the square root. It's negative. So that lets us know we should get 2 complex non-real answers. And did we? We did, right? So that's what that's telling you. It's letting you know ahead of time what kind of answers you should have. All right? If it's positive, then that lets you know there's going to be 2 real solutions. Okay? So negative means 2 non-real solutions. Positive means 2 real solutions. Got that? All right, and then lastly, if the discriminant is exactly 0, that means there's going to be just 1 real solution. Okay, so you do need to know that, because on the quiz and test, they will ask you these things. And then you need to be able to identify what your graph would look like generally based on that information. If you have 2 real solutions, that means your graph is going to cross the x-axis at 2 points. Because remember, a solution is where your graph crosses the x-axis, right? So if you have 2 solutions, it's going to cross twice, something like this. If you have 1 real solution, then your graph will look like something like this, where it crosses just once, where it touches the x-axis at 1 point. And if you have 2 non-real solutions, it's going to look like that last graph, where it doesn't touch the x-axis at all. It doesn't touch the x-axis, but somewhere off in imagination world, it touches an axis in there somewhere. So that's what that is. So then lastly, let's do some examples using this information now. The discriminant. They want you to find the discriminant, so give the number that is the discriminant, and then tell how many solutions you have and what kind of solutions you have based on the discriminant. So you got to find your A, B, and C first. Is A lined up like it should be? Yes, it is. So what is A? What's B? And what is C? Negative 2. So the discriminant, as it says right there, you don't have to memorize that. I'll always give you the formula. It's b squared minus 4 times a times c. So what goes in that first parentheses right there? 5. What goes in the next one?
3.
And what goes in the last one?
2.
Negative 2. So when we solve this, that will be what the discriminant is. So what is this going to be? 25? What's negative 4 times 3 times negative 2? Positive 24. Because there's 2 negatives there. Negative times negative is positive. So we have 25 plus 24. What's that? 49. So 49 is your discriminant. So that's part of the question. Then you want to know how many solutions and what kind. So how many solutions are there going to be? 2. And are they going to be real or non-real? Real solutions. Because this is a positive number. If your discriminant is positive, you get 2 real solutions.
What if it's negative?
Then it's 2 non-real solutions.
Okay.
And if it's 0, you get 1 real solution.
So the answer is 2 real solutions.
Well, the answer is 49 and then 2 real solutions, yes. Yeah, because it asks you, it says find the discriminant, and then it says state the nature of the solutions. That's 2 questions. So let's do number 2, or B. Is B already lined up as it should be?
Yes.
Yes, it is. So what is A?
2.
That's right. What's B?
Yes,
And what is C? 4. Okay, so the discriminant is B squared minus 4 times A times C. What goes in that first parentheses? What's the next one? And the last one? That's right. So let's work this one out. What's negative 7 squared? 49. Negative, it's not 36, 32. All right, so we got 49 minus 32. What is that? Close. 17. Set 5, what? 17. Okay. So based on that value of the discriminant, how many solutions are we going to have?
2.
And are they real or non-real?
Real.
So 2 real solutions. Nice. Nah, it's just 2 real solutions. 2 real solutions.
You're talking about all real numbers.
He's just trying to be lazy. That's what he's trying to do.
Wait, so if
No.
it equals 0, it's 1 real?
Yeah, if it equals 0, it's 1 real solution. That's right. Let's do this last one now. Okay, are the terms in the correct order?
Yes.
Yes, they are. What is A?
5.
What is B?
4.
And what is C?
2.
All right, so we got B squared minus 4 times A times C. So what goes in the first parentheses?
4.
What goes in the next one?
5.
And the last one? 2. So let's work this one out. What's 4 squared?
16.
16. And then we got minus negative 4 times 5 times 2. Negative what? 40. Okay, so what is 16 minus 40? Negative 24. So that's your discriminant, negative 24. And based on that number, how many solutions do we have? 2 non-real complex. That's right. 2 non-real complex solutions. Complex.
What if we put 2 non-real solutions?
If you put 2 non-real, that's fine too. But it is going to be complex. You're never going to have a pure non-real solution. It's going to be complex. You're doing this anyways. All right, and that ends our last notes for the unit. Oh boy. Oh, the bell. So, see you in the next one, which won't be for a while. So until then, peace. All right.